In this video, I am going to discuss about financial mathematics. We need to have an understanding of what is ungrouped data and grouped data when it comes to financial mathematics. Ungrouped data refers to individual observations or measurements that have not been organized into categories or classes. Simply, these are the data which has no categories or these have not been sorted out. Group data refers to data that has been organized into categories or classes. Simply, group data are the organized ungrouped data. The advantage of group data is that it makes it easier to analyze large sets of data by simplifying the presentation of the data. It can also make it easier to identify patterns or trends in the data. There are 25 students in a classroom. Results for an English exam have been given to the students as follows. Results are out of 100, which means this 23 is out of 100. So these are the ungrouped data. As you can see, it is really difficult to get meaning out of these data. So what we do is we group this data as follows, like in this table. Then we categorize these ungrouped data into grouped data. As now you can see, you can clearly read this table. The range is given here and the frequency is given here. It is very simple to understand. This type of group data is known as frequency table or the frequency distribution. Frequency table, or this is also known as frequency distribution. So now we know how many students score below 20 marks, which is 3, and 9 students have scored between 20 and 40. 4 students have scored between 40 and 60. There is another important characteristic you need to know about the frequency table or the frequency distribution, which is that all the frequency values should be equal to the total frequency, which is the summation. In this example, there are 25 students. So the summation of these each individual frequency should be equal to 25. Let's calculate and see. 3 plus 9, 12, 16, 22, 25. This is correct because there are 25 students in a classroom. Another important thing you need to know about when it comes to frequency table or frequency distribution, which is this variation can be indicated like this as well. These two are the same, which means the value is between 80 and 100. You need to know about this standard. This is how we read this. X is greater than 80 and less than 100, which means X is between 80 and 100. Now let's discuss about the frequency distribution or the frequency table we just discussed earlier. A frequency table is a table that summarizes the distribution of a set of data by showing the number of times each value or range of values appears in the data. Frequency tables are often used in grouped data as they can provide a clear and concise summary of the data. Now we know about this. There can be two types of data or variables in a frequency table. Now let's talk about what is discrete data. Discrete data refers to data that can only take on specific values within a defined range. For an example, number of customers who enter into a store in a day. We can only have whole numbers of customers such as 0, 1, 2, 3 and so on. This data is considered to be discrete. Simply, discrete data can be used when it comes to whole numbers because the number of customers who entered into a store in a day should be a whole number. It can be also zero. This means there have been no customers entered into the store in a day. So here is an example. Number of customers per day, and they have given the frequency. Frequency denotes by simple F. The other type of data is continuous data. Continuous data refers to data that can take on any value within a defined range. For an example, amount a customer has spent when purchasing from the store. Transactions can take on any value within a range, including fractions or decimals. This data is considered to be continuous because the transactions can be decimal. Let's say $1.5, $2.75. These are not whole numbers. Now let's talk about the financial mathematics, arithmetic mean. This is also known as the average. Arithmetic mean, also known as the average, is a commonly used measure of central tendency in financial mathematics. It is calculated by adding up all the values in a set of data and dividing the sum by the total number of values in the set. This total number of values in the set is the total frequency. As we discussed earlier, there are ungrouped data as well as grouped data. So when it comes to financial mathematics, we have to use separate techniques to calculate the mean for ungrouped data as well as for grouped data. There are 25 students in a classroom. Results for an English exam have been given to the students as follows. Results are out of 100. So what we have to do is we have to calculate the mean. Mean is the average. So for ungrouped data, we can use this formula to calculate the mean value, which is sigma values divided by the number of values. Here what we have to do is we have to calculate the summation of all the values, then divide by the number of values. So here the mean of this ungrouped data is equal to, let's say there are numbers repeating again. It doesn't matter. We have to take all the numbers for the calculation. So the summation of these values should be divided by the number of values. Number of values here is 25. So the mean for the ungrouped data is equal to 46.92. This is the average of the data set. We cannot use the same method to calculate the mean for grouped data. We have to use a different technique. Now let's talk about that. These are the grouped data. For the group data, we have to calculate the mean by using this formula. Sigma fx divided by sigma f. X is the midpoint of each range. Now let's calculate the mean for grouped data. So the range is given here. Now we have to calculate the midpoint for every range. This is how we calculate the midpoint. We add the two values 0 and 20, then divide by 2, which is equal to 10. So 10 is the midpoint of the 0 and 20 range. So these are the x values. Now what we have to do is we have to multiply the respective x value with the f value, which is the frequency. So the fx for the first range is 30, which is 10 multiplied by 3, 30. Now we have to calculate the sigma fx value, which is the summation of all these values, which is equal to 1190. We also have to calculate the sigma f value, which is the summation of all these values. We know this is 25 because there are 25 students in the classroom. Now we can calculate the mean for the grouped data, which is equal to sigma fx divided by sigma f. This is equal to 1190 divided by 25. This is equal to 47.6. So this is the average value for the grouped data. Now let's discuss about the mode. This is really simple. The mode is another measure of central tendency that represents the most frequently occurring value in a dataset. In other words, it is the value that appears most often in the dataset. Simply, this is the value in a dataset that appears mostly. So look at the given ungrouped dataset here. 5, 7, 10, 5, 8, 9, 5, 6, 2, 1, 7. Now what we have to do is we have to find the most frequently occurring value in this dataset. So let's go through the values one by one. 5, 1, 2, 3. There are 3, 5 values. 7, 1, 2. There are only 2, 7 values. 10. There is only one 10 value. 8. 8 is also one time. 9 also one time. 6, 2 is also one time. Now we know the most frequently occurring value in this dataset is 5 because it appears in the dataset 3 times. So 5 is the mode of the given ungrouped dataset. Now let's talk about how to find the mode in a grouped dataset, which is here. This is the frequency table. It is really simple. We have to identify the highest frequency for any range. These are the frequencies 3, 9, 4, 6, 3. Highest number is 9, which means there are 9 numbers between range of 20 and 40. So range 20 and 40 is the mode of this dataset. Now let's discuss about the median. The median is a measure of central tendency that represents the middle value in a dataset when it is arranged in ascending or descending order. It is the value that separates the dataset into two equal halves, with half of the values below the median and half of the values above the median. If the dataset has an odd number of values, then the median is the middle value. If the dataset has an even number of values, then the median is the average of the two middle values. Here is the previous example again. First of all, what we have to do is we have to rearrange this ungrouped data into an ascending order or to a descending order, which means lowest number to the highest number or highest number to the lowest number, whichever you want to do, ascending or descending. So first of all, let's rearrange this dataset into ascending order. This is the data in the ascending order. Now what we have to do is we have to remove one value at a time from each end. So one value from this side and one value from this side. One value from this side again and one value from this side. Likewise, we can remove one value from both ends until we find out the middle value of this data set. So this value is left here. This is the median of this data set, which means this is the middle value of this data set. This value divides this data set into two halves. So to the right side there are 12 values. To the left side there are 12 values. With this value, there are 25 values in this data set. So the median value is 46. In the real life, this method is really difficult to conduct because the dataset can be very lengthy and complex. So what we can use is we can use this formula to find the median unit. This is not the median value, this is the median unit. This calculates the position of the median value. So now let's calculate and see whether we can obtain the median value for the above dataset. N is 25 as now we know, plus 1 divided by 2, which is equal to 13. This is the 13th position, which means in the data set 13th number is the median value. Now let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the 13th value and this is the median value. Do not get confused with the median unit and the median value. Median unit is the position of the median value. There were only 25 values in that group of data, which means it is an odd number. When it comes to odd numbers, the median value can be obtained directly. But what will happen if there are even number of data in a data set? Now let's calculate and see. This is the same example as before, but now there are 26 students and I have added the 99 score as the 26th value. Now let's find out what is the median value for this data set. First of all, let's rearrange this data set into an ascending order or into a descending order. This is the data set in the ascending order. Another important thing to note is that there are 246 values and 278 values. Do not ignore the values just because they are repeating. Consider all the values, whether it is repeating or not. So now let's remove one value from each side one by one. So now as you can see, these two values are left here. Now there are two values because there is an even number of values in the data set. Now how we can find the median value? What we have to do is we have to take these two values and take the average value of these two values. So 46 plus 46 divided by 2, which is again 46. So this is the median value. Now let's calculate the median unit. Median unit is n. N is 26 plus 1 divided by 2, which is equal to 27 divided by 2, 13.5. This is the position of the median value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the 14. The median is between these two values, 13.5. This is how we calculate the median for ungrouped data when there are odd and even number of values. Now let's discuss about how we can calculate the median for grouped data. This is the frequency table. In order to find the median value, first we have to calculate the median unit. N is 25 plus 1 divided by 2, which is equal to 13, which means the 13th value is the median value. We cannot find the median value as before. We have to use this formula in order to find the median value for grouped data. So then what we have to do is we have to calculate the cumulative frequencies in order to find the 13th value. Now let's do it. This is the cumulative frequency. What we are going to do is we are going to add the frequencies one by one. So this is 3. 3 plus 9 is equal to 12. 12 plus 4 is equal to 16. 16 plus 6 is equal to 22. 22 plus 3 equals to 25. These are the cumulative frequencies. Now what we have to find, where is the 13th value? This is the first 3 values. This is the first 12 values and this is the first 16 values. So the 13th value is in this range, 40 and 60 range. Now we can calculate the median value. Median value is equal to lower boundary of group which contains the median. So 40 to 60 group contains the median. So the lower boundary is this. This is the lower boundary 40. So capital L equals to 40 plus n is equal to 25 divided by 2 minus A. A is the cumulative frequency of the group before the median group, which means this value 12. Cumulative frequency of the group before the median group. This is the median group. So this will be the group before the median group. So 12 divided by simple b. B is the frequency of the median group. Frequency of the median group is 4 multiplied by W. W is the width of the median group. Width is the difference of this range. 60 minus 40 is 20. This is the width of the median group. So this is 20. These parentheses are very important. So the median value is 42.5. This is the median value. Now let's discuss about the range. Range refers to the difference between the maximum and minimum values in a dataset. It is really simple measure of variability that provides an indication of how spread out the values are in a dataset. This is how we can calculate the range, highest value minus the lowest value. In the context of business, higher range generally associated with higher risk, which means higher the range, higher the risk will be. Lower the range, lower the risk will be. This is the same example as before. Now what we have to do is we have to calculate the range. Range is equal to the highest value minus the lowest value. So the highest value of this data set is 94 and the lowest value of this data set is 5. So the range is 89. This is really simple. This is for the ungrouped data. When it comes to grouped data, we can use this 0 as the lowest value and this 100 as the highest value. So the range equals to highest value minus lowest value, which is equal to 100 minus 0, which is equal to 100. Now let's discuss about the standard deviation. The Greek letter sigma denotes the standard deviation. Standard deviation is a commonly used measure of risk which is more accurate than range. It is a statistical measure that indicates the extent to which the data of a dataset varying around the mean value. Higher the standard deviation, higher the risk will be, and vice versa. For ungrouped data, this is the formula to calculate the standard deviation, which can be denoted by sigma. N is the number of values, x is the individual data value, x bar is the mean value. Now let's calculate the standard deviation for this example. So the simple n is 5 because 1, 2, 3, 4, 5 values are here. Now what we have to do is we have to calculate the x bar. X bar is the mean value. Since this is ungrouped data, we can calculate the mean value by adding up all the values and dividing by the number of values. So 2 plus 9 plus 7 plus 5 plus 6 divided by 5. This is equal to 5.8. So x bar is 5.8. So now what we have to do is we have to calculate the x minus x bar value for each individual value and then take the square of this value. Let's directly assign these values. So standard deviation is equal to square root x is 2 minus 5.8 squared plus 9 minus 5.8 squared plus 7 minus 5.8 squared plus 5 minus 5.8 squared plus 6 minus 5.8 squared divided by n is 5 square root of all these values. So sigma is equal to 2.315. Now let's discuss about the variance. Variance measures the average square deviation of each data point from the mean. Simply, variation is the square of the standard deviation. This is really simple. Now let's calculate the variance for the previous example. Variance is equal to sigma square. Sigma is 2.315 square. This is equal to 5.359. This is the variance. This is also a measurement of the risk. Finally, let's discuss about the coefficient of variation. This is the ratio between the standard deviation and the mean of a data set. Higher the coefficient of variation, higher the risk will be, and vice versa. Coefficient of variation can be calculated by using this formula: standard deviation divided by the mean. Now let's calculate the coefficient of variation for the previous example. Standard deviation is 315 divided by the mean. Mean is 5.8. 5.8. This is equal to 0.399. Thank you for watching. See you in the next video.